11 advanced, term 2, 3.2, work and energy, free response. We have a tractor, question number 1, pulls a field tree along the ground for a distance d, and it is exerting this much of force, and we can see that it is pulling it in the same direction of the force, so the theta here is equal to 0. Applying work is force by distance by cosine of the angle, so it is 5,000 by 200 by cosine of 0. It will give me a total of 1 million joules, which is 10 to the power of 6 joules. So number 2, how much you have a force of 10 applied to a block that is pulling it 50 meters distance and at an angle of 30. Also the work is force by distance by cosine of this angle, applying everything by its value. So I will have 433 joules. Now I need, when a car brakes, it slows down due to the friction force between the tires and the road. The force opposes the motion as shown in the figure below. If the friction force is a constant 500 Newton and the car comes to rest in 25 meters, how much work is done by the friction force? So basically, the force is backward, as you can see, and the displacement is forward. So I see that the force and the distance are having 180 degrees. So the work of friction equals to the force of friction by the displacement by cosine of 180. So this 500 by 25 by -1, so basically negative 12,500 joules. Question number 4, I have a force position graph. I need to find first the work done by the force from x equals to 0 to 2. So pay attention to whenever the question specifies the interval, so I only need this part. The work is the area, which is here an area of a triangle. So the base is 2, the height is 0.8, so it is 0.8 joules. Question B, I need to find the work from 2 to 4. From 2 to 4, this means I have to find this area now, which is very similar to the first one, but not to forget that the base is not 4. The base is only 2, from 2 to 4. And the same height, so also the work is the area. Half the base is 2, and the height is 0.8, so 0.8 joules. The total work is actually the sum. The work total is the first work and the second work, which is 0.8 and 0.8, so 1.6 joules. Question 5, I need to calculate the work done by the force by the graph, the whole thing. So I will divide it into the first triangle and the second triangle, the second area, which is a rectangle, and finally another triangle. Now the area of each, let me do it here. So here the work is half base times height. The base is 5 and the height is 300. So 0.5 by 5 by 300, so 750. Now later I will add it to the other ones. Here the work is length by width, which is here the width is from 6, 7, 8, 6, 7, 8. So the base is here only 3. So 3 by 300, it will give me 900 joules. Finally, this work is a triangle, half base times height. The base is 2 from 8 to 10. And it is half by 2 by 300, 300. Now the total is actually their sum, which is the 750 مع the 900 and the 300. So basically it is 1950 joules. Question number 6. You have a 1,000 kilogram car accelerates uniformly from 100 kilometers per hour. Ignoring air resistance and friction, calculate how much work was done by the car engine. So basically from rests, this means that V initial is 0, and the final velocity here, I don't like its unit. So converting it to meters per second, I simply will divide it. We agreed we'll divide it by 3.6, so it will be 27 meters per second. So the work is actually the change in kinetic energy, and because the car will start from rest, so I will only have half by 1000 multiplied by 27 squared, which will give me 3, 8, 6 and 3 more zeros, or 3.86 times 10 to the power of 5 joules, or 386 kilojoules. Number 7, I have a block of mass 2.5 kilograms slides on a rough horizontal surface. The initial speed, so here I have my rough, very rough. So let's imagine we have like a rough place here. So it is a bit rough. We have a block that was moving with a speed of 8.6 meters. Moving, and finally it here stops due to friction. So basically it was encountering a backward force while the distance was forward. Now I need to find the magnitude of this frictional force. Now I will simply use that the work not only equal to the force of a friction multiplied by the distance multiplied by cosine of 180, because they are opposite to each other. I will also use that it is equal to the change in the kinetic energy, and looking that it will stop eventually later, so this will be equal to 0. So I will be left with the force of friction. The force of friction here, Fk, I don't know, over the distance of 16 meters. Cosine of 180 is -1. And here I have -1/2. The mass is 2.5. And the velocity initial squared was equal to 8.6 squared. Now I will simply just put it here as 5.8 Newton. Now this question integrates two sides of the work, two faces. So it is equal to Ft cosine, and also it is equal to the change in the kinetic energy. So two sides of the force. Question number 8, you have a car of mass 1000 accelerates from rest to 100 kilometers in 5 seconds. I need the power, but first I need to convert this into meters per second. So I'll divide it by 3.6, again 27 meters per second. And from rest, this means that the initial speed was 0. To find the average power, first I need to find the work. We have done it, by the way, once back here. We only found, yes, here, the same values. So the work is actually the change in the kinetic energy. And because I need the power, I will divide by the time. So the work that I got first was big, 386,000 divided by 5, which will give me 78,400 watt. Finally, with question number 9, you have driving safety organizations are worried that electric cars are more powerful than diesel cars, causing them to be very dangerous. In a test drive, the thrust from an electric car engine is 200 Newton when the car maintains a constant speed of 27. To know the power, I will use that it is equal to the force multiplied by the constant speed, which is 200 by 27, giving me 5,400 watt. Thank you.